Hello, everyone, and welcome to our session, OpenTelemetry Collector, telemetry built into all software. Thanks for joining us. First off, I'd like to introduce ourselves. My name is Steve Flanders. I'm a Director of Engineering at Splunk. I'm also an OpenTelemetry Collector approver. Been working in the observability and monitoring space for the last decade and was actually contributing to the Open Census project prior to it joining with Open Tracing to form OpenTelemetry. And joining me is Trask.
Hey, I'm Trask Stalnaker. I'm a software engineer at Microsoft. I'm a maintainer on the OpenTelemetry Java instrumentation project. And I've also been in the monitoring business, sort of, well, open source business at least, for a decade. I wrote and maintain an open source Java monitoring tool called GlowRoot, and enjoy that space so much that here I am in OpenTelemetry world now.
Awesome. So our agenda for today, I want to give you a quick introduction to what the OpenTelemetry project is, talk a bit about the OpenTelemetry collector and how it fits into the observability picture, then do the same thing around auto-instrumentation, focusing primarily on Java, though we will touch on other languages as well, and then really wrap it up with a demo showing you how to really get started with the OpenTelemetry project. So with that, what is OpenTelemetry? OpenTelemetry is a CNCF project, and it's really looking to solve a pretty big pain point in the observability space. If you've heard of observability, you've probably heard of the three pillars of observability being the different data sources that you have in your environment: traces, metrics, and logs. Well, for each of these different data sources, there are actually different layers to it. You have the API, you have the implementation of that API, all the data collection aspects, and then things like wire formats, interrupt formats, and the like. Some of these things are actually language specific. So when you start talking about instrumentation APIs, they have to be written for each individual language, where the agent and collector mechanisms have different deployment methods depending on the type of architecture that you're deployed into. OpenTelemetry is really looking to solve all of these aspects. The idea is everything that you deploy within your environment to get telemetry data out, OpenTelemetry is providing a completely vendor agnostic solution to get that telemetry data to the backend or backends of your choice. OpenTelemetry actually does not offer a backend, though. That's where it kind of draws the line. Anything instrumentation, data collection, even things around semantic conventions are all included, and then you can choose either an open source or commercial backend to send your data to. Now, the OpenTelemetry project is currently in beta for most of the languages. There are a few that haven't reached beta yet. There's been an extensive focus on tracing to start, so that's quite mature. In fact, the specification has already reached its first stable release. The metrics one is actively underway, and that should be wrapping up later on this year. It will also be stable by the time we get to GA, and GA is planned for later this year. So a lot of active contributions going on now. And again, this is really the joining of two other projects, Open Census and OpenTelemetry. Now, another interesting fact for you, OpenTelemetry is extremely active. In fact, it is the second most active project in CNCF behind only Kubernetes, according to the CNCF dev stats. So let's talk about how you would deploy OpenTelemetry into your environment. So if we think about having one or more hosts, each running one or more applications, and maybe we want to send the data to one or more different backends, the typical recommended approach would be to go ahead and deploy the OpenTelemetry collector as an agent on each of your hosts. That will allow you to actually collect host metrics automatically and also provides a way to collect tracing information. Now, that tracing information as well as application metrics can come out of OpenTelemetry client libraries. These are going to be language specific, and out of the box are actually configured to send directly to the OpenTelemetry collector. So if you deploy it without configuration, you'll actually have telemetry data being emitted for the auto-instrumentation libraries, which is pretty cool. And then in addition, you can also deploy the OpenTelemetry collector as a standalone service if you want to handle more advanced use cases, maybe around protecting from a security perspective, limiting the number of egress points or controlling your API tokens, or if you want to do more advanced functionality such as tail-based sampling in the case of APM. Now, if you look at the OpenTelemetry collector as a single component that exists, it's actually one binary that can be deployed in a variety of different form factors depending on your needs. It's really looking to make it easy and provide a vendor agnostic way to collect this data. So it actually receives many open standards today, like Jaeger, Prometheus, and Zipkin, and it can export to both open source and commercial backends. So in a way, it handles translation for you. It understands the formats it's receiving and how to send that out in a different format. In addition, it can be used to manipulate the data before it gets sent out. Maybe you want to do like PII redaction, or you want to do metadata enrichment. All this is made possible through the collector as well. Now, why would you want to actually deploy a collector? Like, why not just have the client library send this data directly to the backend? The idea is really to offload the responsibility from the application for two primary reasons. One is you don't want to have to implement it in every single language. Like, trying to keep that consistent is really, really hard. And even the implementations are going to change because they're language specific. Second, you really don't want to introduce too much overhead to the application. So you want to do the minimum necessary to gather the data that you need. That's why we recommend deploying the OpenTelemetry collector as an agent. You can actually have the instrumentation pass off this data quickly, and then have the agent handle this in a unified way and be able to handle things like buffering and retry, compression, encryption, all the things that you'd care about that could be additional overhead to your actual application. So really the idea here is time to value, make it very, very simple, offloading of responsibilities, and really providing a consistent experience end to end. Now, if we think about the architecture of the collector, basically it has a notion of receivers, how you get data in. This is both push and pull based. As I mentioned, it already supports many of the open source standards, including Jaeger and Prometheus. It has a notion of exporters, which is how you get data out. And again, it supports both open source as well as vendor or commercial specific backends. It has a notion of processors, which is a way of manipulating the data as it passes through the collector. So this handles things like batching and queued retry, but as I mentioned, also PII redaction, tail-based sampling, and other specific scenarios. Now, what you end up doing is actually defining what we call pipelines in the collector. So for example, I can say that I'm receiving traffic over OTLP, maybe I'm going through a batch and queued retry processor, and I'm exporting in Jaeger. As I mentioned, it handles that translation of data format for you automatically. You could then define a second pipeline where, again, maybe I'm receiving from OTLP, which is OpenTelemetry's format that it includes by default. That's what the auto-instrumentation and other client libraries follow today. And I could have that then export to two different destinations, OTLP and in this case, Prometheus. So there's a lot of flexibility and choice via configuration. What's really nice about this is you don't have to actually go make code modifications to take advantage of these capabilities. It all happens in the collector itself. There's also a notion of extensions. It's just a way of typically doing health checks and profiling, but it's also a way of handling things that might be outside typical data flows for the telemetry data that you're collecting. Now, the collector actually has what's known as the core repository as well as a contrib repository. In core, you have all the open source aspects. And as you can see here, it's pretty broad support for both traces and metrics. In the case of OpenTelemetry, logging is just starting to pick up. So eventually logging will be added as well to both client libraries and the collector, but it's still early for that. The expectation is that there'll probably be a beta later this year for it. In the case of contrib, these are more community-based. So this could be vendor-specific logic, or it could even be open source software that only applies to a smaller subset of the user base of OpenTelemetry, but it's a way of adding things that are outside the core functionality of OpenTelemetry as a whole. Again, you can see pretty rich adoption here. In fact, in general, 2 of the 3 major cloud providers, Azure and GCP, are already instrumenting the backend services. AWS is just getting involved right now as well with the project. All the major vendors are also contributing at least exporters, if not other aspects to the project. And you're also seeing broad adoption and support from many end users as well. With that, I'd like to turn it over to Trask, and he can tell you a little bit more about Java auto-instrumentation.
Sorry, was muted. All right, so the goal of auto-instrumentation is to give you as much insight into your production system as possible with the minimum amount of effort. So is to get you up and going and starting to see what's happening in your app. In the case of Java, and to enable the OpenTelemetry, Java auto-instrumentation, you just need to add this Java agent command line arg to, for example, all of your microservices, and maybe an environment variable to tell them where to send the data to. As Steve mentioned before, by default, it will send to the agent, the collector agent that's running if you're running that locally. Just with that minimum amount of effort, you get this beautiful distributed trace flow picture in your backend monitoring system. In this case, it's a screenshot from Jaeger, which is another CNCF project. So you get a lot of visibility. So I did want to mention what we're doing in the OpenTelemetry Java auto-instrumentation project is not new. The Java ecosystem has a rich history of codeless monitoring solutions. We've had commercial monitoring tools doing codeless monitoring for a long time. We have open source monitoring systems doing codeless monitoring for at least 10 years. More recently, some commercial monitoring tools have been open sourcing their Java agents, which has been really great because I like to have access to all the source code of any library or agent that's running in my production system. And I imagine I'm not super unique in that way. And a special call out here to Datadog, who donated their open source Java agent to OpenTelemetry as the starting point for our work in this community. And lastly, I'd be remiss not to mention a couple of open source libraries that make this auto-instrumentation, bytecode instrumentation possible in the Java world. ASM, a low-level bytecode instrumentation library that's been around forever, and ByteBuddy, a higher-level bytecode instrumentation library built on top of ASM that has been around the last few years and been widely adopted by most of these types of auto-instrumentation projects. So that brings us to OpenTelemetry, the OpenTelemetry Java auto-instrumentation project. And it is really, I see it as a community dedicated to building and maintaining vendor-neutral Java instrumentation. Also, another important aspect of the work is working with other OpenTelemetry communities, other language communities, to provide consistent telemetry across different programming languages. So in that way, I think is sort of the unique, the new thing that the OpenTelemetry communities are bringing to this evolution of Java auto-instrumentation. And while we've been focused on tracing so far, definitely we are working towards having metric support, and then, as Steve mentioned, in the future also logging capture with the same infrastructure. So this is the list of all of the instrumentation, all of the Java libraries that we have instrumentation for so far. And so with auto instrumentation, it's important to, so if you are using these particular libraries, we will instrument those at runtime via the Java agent and capture the calls, the requests coming into those libraries, the calls going out of those libraries, what your JDBC SQL calls look like. And so this is where we really think that the power of the community coming together can grow this list over time, supporting, as new versions come out, supporting new versions. So the more people we have, the more vendors, the more community members, who are all working on this common auto-instrumentation, the more support that the Java users will get automatically out of the box. So one question you might be asking is, auto-instrumentation is great, but what if I want custom telemetry also? And so I like to recommend starting with just auto-instrumentation out of the box, try it out. That way you can start, seeing telemetry flow to your backend monitoring system. And then you can start to layer in custom telemetry on top of that or inside of that. So depending on the complexity of your needs, there's a couple of different ways to add custom telemetry into your application, as well as, for the OpenTelemetry API is a full-blown telemetry API, and the auto-instrumentation auto-correlates, captures and auto-correlates everything that's coming from the OpenTelemetry API. So those two projects blend really nicely together. For sure, more auto-instrumentation customization hooks coming as we run into, as community members, bring new use cases, things that, so we look forward to growing this project and hearing from everybody. So I wanted to end here with, I think my favorite thing about or at least one of my favorite things about this project is that you can take all of this great auto instrumentation and your custom telemetry too, to the backend monitoring system of your choice. So this way, this community is really focused, like Steve mentioned, on the gathering side, not the backend monitoring side. So we can really focus on having really great auto instrumentation, really great library instrumentation, and then the backend monitoring systems, vendors, open source solutions, just need to provide their exporter for OpenTelemetry. And that can either be directly, for example, on the Java side, you can have a Java exporter that sends directly to your backend monitoring system, or if you're going through the collector that Steve talked about, the backend monitoring systems, they only have to write their exporter once for the collector, and then the Java auto instrumentation flows to that backend system, same with other language instrumentations. And speaking of other languages, so auto instrumentation is growing. We've got a JavaScript community, a Python community, Ruby community, and .NET is just getting going. So this is the instrumentation is a great way to get involved in the community because you can take your favorite language, your favorite library, and go and see how you can contribute instrumentation for that particular library. If your favorite library and language is already instrumented, go and test that out. See if it works the way you would expect as an expert in that library, and let us know if we got something wrong. So again, that's a great way to get started in the community.
Cool. And next up, we will do a quick demo to kind of show you how to get started with both Java auto instrumentation as well as the OpenTelemetry collector. So to kick us off here, I'm actually going to start up a Docker Compose file. And while it is booting up, I'll walk you through exactly what it's doing. So what I've done is I've taken the Spring Pet Clinic microservices repository, and it actually contains a Docker Compose file made up of multiple Java microservices, as kind of outlined in this architecture diagram that you see here. So it's going to spin up a variety of different containers, And what we've done is actually modified it to add OpenTelemetry Java auto-instrumentation into it, have it send to an OpenTelemetry collector, and have it forward that data to a Zipkin server so we can actually see it on the other end. So from a diff perspective, basically what we did is add a collector.yaml file. So you actually configure the OpenTelemetry collector through YAML. And here you'll see that we have configured a receiver, basically the OTLP one, which is the default one that Java Auto Instrumentation will send data out as. So we're just receiving over OTLP. And then we are going to export to a Zipkin endpoint. That is a different Docker file that is running inside of this microservices-based architecture. So that's just a one-time config for the collector. Again, if I want to add different processors, I can go ahead and do that here. In this case, it's just a pretty standard configuration. Next up, we went through the Docker Compose file, and as Trask mentioned, you basically just add this Java agent flag. So you have to go ahead and tell it where the jar is for the OpenTelemetry Java agent, and then specify what the service name is. So we also set an environmental variable. So for each of the Docker containers, we added that Java agent flag, and we added the environmental variable so that we'd see these as different Java services in our waterfall view or service graph, depending on the backend that we are using. So you can see that for all the different Docker containers. And we added the OpenTelemetry collector as another Docker container that gets fired up into this Docker Compose. It uses the collector.yaml file that we just showed at the beginning. And the only final thing is that all the Docker containers that you're seeing in the Docker Compose actually get generated through this Docker file at the end, where we have to tell it to go grab the OpenTelemetry Java agent jar based on the latest version that's available in the OpenTelemetry repository today. So that's really the only changes here. You'll notice no Java changes, no recompiling of the code. We've just pulled down this jar, specified the Java agent, set the service through an environmental variable, and deployed the OpenTelemetry collector. And the net result should be that we see telemetry data coming through our system. So let's go ahead and see if that's happening. So we are in a Zipkin here. We'll go ahead and look at the service name, and you can see that services are starting to appear already. We can go ahead and look for individual traces, and you can see the traces are starting to come into the system. So here we have a discovery server or service that's calling a config service. You can see that this is actually using the OpenTelemetry SDK, and we actually get some semantic conventions and metadata automatically provided for us. So you can see this is RESTful services. We can see the status code. We can see which methods being used. So again, some pretty rich information. If there were errors, like 400, 500 level errors, they would also show up here. And as the app gets hit more, you'll actually see that a variety of additional microservices will start to show up. As you can see now, we actually have several calls coming into the system. And so each individual request, no matter which microservices it hits, it'll go ahead and generate trace data for that. So again, very simple to get started. You can take basically any Java application that's using one of the supported libraries that Trask showed earlier, go ahead and add the jar and collector, and you can go ahead and send this to your backend, or you can even log it locally and just see what data is being generated. It's pretty easy to extend this. Like if you want to add additional metadata, you can do that through environmental variables in the auto instrumentation itself, or as a configuration addition to the OpenTelemetry collector. Quick and easy.
Yeah, so Steve and I were both super excited to share the OpenTelemetry work that's going on with the folks, with new folks, and we would love to have you join the conversation, join in the project, whether that's as a testing it and providing feedback, providing code. There's a couple ways to get started. There's a couple of Gitter channels. If you post there, you'll find a bunch of people monitor those, bunch of friendly folks. Join a SIG. If you go to this link, you can find your favorite programming language or your favorite topic like logging or metrics. And there's weekly SIG meetings, and there's Yeah, and like I mentioned earlier, instrumentation is a great way to get started, I think, biased. Again, take your favorite language, take your favorite libraries, go test it out if it's there and provide feedback, or if it's not there, ask for help on how to get started. And we'd love to see you.
And that wraps up our talk. Thanks so much for joining us, and we hope to see you involved in the OpenTelemetry project soon or trying it out and providing feedback. Thanks a lot.